Kia ora, just answering page 31 of the D&D Algebra book. Okay, let's just get straight into it. Talia's sports car has depreciated in value from an amount $28,940 to $20,000 over a period of 5.5 years. So the value in dollars of the car, blah 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 blah. Y equals A R T. Beautiful, beautiful. Where R is a constant. Okay, so what we're going to do is get our heads around what each thing is. So Y is the current value. This is must be the initial value. This is going to be the rate, and then this is going to be time. Right, so we're just going to break down the formula first. We know that time is in years, and yeah, the thing to notice with the rate here is it's actually going to be it's depreciating, right? Because, well, let's just have a look at it. So let's substitute in what we know. So we know that it's down to $20,000, which is Y, and it started off at $28,940. Well, that looks too much like a 6. I'm just going to round it off. And then there's some rate, which we don't know yet, and to the power of 5.5. Okay, so the thing about the rate is we generally think of it as like a percentage, right? So like maybe 2% or something. But this one's going to be depreciating. So the way I like to do rates is I do 1 plus the percentage. So it's going to be 1 plus 2%, so 0.02. Or when something's depreciating, I do 1 minus 0.02. So this is how I deal with rates, right? But these, I think it will just pop out nicely anyway, to be honest. Okay, so let's just deal with this. So the first thing is you can unpack anything in algebra using BEDMAS backwards. So Sam, Deb, is it subtraction? No. Addition? No. Multiplication? Yes. This is multiplication. Yeah. So if I do 20,000 over that number, let's just do it in our calculator straight away. So we're going to go 20,000, oopsies, divided by 2, 8, 9, 40. We've now got the 69. Man, this is a very arty question indeed. Okay, so 0.691, I'm feeling 3DP these days, equals R to the power of 5.5. Nice, very nice. Okay, now what I want to do from here is I'm going to need my formula sheet. Okay, so we've got our log. This is just going to be the basic log law, right? If we've got y equals b to the power of x, then x equals log b y. Easy. If y equals okay, good to get my head around this. Normally I do logs the other way, so I would normally shift it over and then do all my rearranging, but I'm going to try and use their formula today, get my head around it. So it's going to be 5.5. Oh, that's not going to help us at all, is it? The power is going to be equal to log base R. Oop, no, that's not going to help at all. Okay, we're going to have to find a more clever way to do this. Oh, we can just do the 5.5 root. What am I doing? Root 5.5 of 0.691 is going to get us R. Yeah, that's way easier. To do that in our calculator, we can do this like a little X root button. The reason I did that is because it's just the opposite of something to the power of 5.5 is just doing the 5th root. I don't know if that's the right way to say it, of something. Is this the rate that I was expecting? Yeah, because this rate is, it comes out looking kind of like one of these numbers, right? So yeah, I'm into that. Okay, so R equals 0.935. Right, so then if we were using this percentage thing, we could then say that, I'm pretty sure this would be fine, but depreciating at a rate of 6.5% per annum. And that's compounding, right? How did I get that? Because 1 minus 0.935 equals 0.065. Right, and then there it is there. Oopsies, working a little bit messy today, to be honest. Okay, let's move on. Next question. Let's drag it down here. Okay. Begin through now. Okay, the value after 8 years. Okay, so all we need to do is 2894t, and then we're going to chuck our rate. It's already good to go. 935 to the power of 8. This question is a little bit 28,940 times 0.935 to the power of 8. Yep, seems about right. 16,904. Make sure it's in dollars. Sweet. Okay, cool. Next question. At the same time as Talia bought her car, her friend also bought a car valued at $32,000. It is depreciated at a rate of 8.5% per year. After how many years will the cars have the same value? Nice. Good question. Good question. Okay, so negative 8.5%, right? First thing I'm going to do is just get that looking like a nice number. So that is the same as 1 minus 0.085, and that is going to get us to 0.915. So this is friend. This is the rate of the friend, right? So what we're going to do is we're going to get Talia on the left, we're going to get the friend on the right, and we're just going to get their things, and we'll just find out when are they equal to each other. So Talia's one, we know it, it's 28,940, 0.935 to the power of t. That finds her one. Now let's find her friend's one. Her friend's car starts off at 32 grand, and then we chuck on a friend's rate of 0.915, and then we put that to the power t, and we're going to have to try and solve for t. Okay, there's a couple of ways to do this. The easiest way would be just to go to your calculator and go into equation. So if you just go to equation, it'll be in a different place in your calculator, and you could just go and do a solver for that. So you could just go 28 blah 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 to the power of, and then this x here, and then just do a shift equals here. But we're going to do it manually because not everyone has a graphics calculator. So what I'm thinking is we get all these together and then these together. So I'm actually going to go and put everything with t on the left hand side. So it's going to be 0.935 to the power of t, and I'm going to divide it by this here. So treat this as like a times, and then this whole thing is b, and then this is c times d. So pretty much I'm going to divide by d. I'm going to divide by this whole thing over 0.91. I probably should have taken this out of brackets, make it a little bit tidier. And then I'm just going to divide by 28,940. 32,000 over 28,940. Now I'm going to use a little trick here. I'm going to use the fact that we can this an exponent law, that if I have something to an exponent over the same exponent, I can just put them together. 0.935 over 0.915. Now, the reason I did that is because then I only have one t. When you have two of something, it's quite hard to, your goal is to try and get it down to just one of those things, or combining them. 32,000 over 20. I could do that on my calculator. $28,940. Her car is 10.6% more valuable. 3DP, we'll stick to it. Okay, so now we should be able to, I think this is a standard, I think now we can finally actually use that log law that I was looking at, right? Because when it's here we go. So it's y equals b to the power of x. It's whenever the power or the exponent is the unknown, that's when it becomes useful to use this log law to solve it. So we can do a little switcheroo here. So we can now say that t is equal to log of the base, oh, maybe I should find this thing here. I'm just going to quickly find that. It will make the working out look way tidier. 0.935 divided by 0.915. That's 1.022. That's just so that I can write a nice little log down here. 1.022. See how the base of the power, b, is the base of the power here, so that means that when it's log base b, it goes down here, and then it was our original y equals, which is this, gets put on the end of the log, so it's 1.106. There's actually normally multiple ways to solve these, so just because your way is different, as long as you get the same answer as me, then you should be fine. Our calculator is actually incapable of doing this log, and maybe the new ones are, so we're going to have to use my favorite log law, and they don't actually give you my favorite log law. My favorite log law is this. If you've got log, let's use some letters, alpha, beta, right? All you can do if you want to get a base to something you can do on your calculator is you do log, and I just remember it's the higher of these two, so the beta is higher, so I put the beta on top, and then the alpha is lower, so I put the alpha on the bottom. And you can do any base on these logs. So my calculator's natural base is, the ln one does log base e, and that log button does log base 10. So I'm just going to do log base 10 for all you engineers out there. So I'm going to use that law here. So it's going to be log base 10 of 1.106 over log base 10 of 1.022. So then now I can do that in my calculator. I'll do it in one fell swoop, log 1.106, and I'm going to make sure I use the divide sign, because then it will do the log function before it does the division. If I use the fraction symbol, I think it might override that. Might be wrong though. So that comes out at 4.62, oops, no, 630. Now, this is t. This is a t value, right? So this is in years. Well, let's check the question, because sometimes you sort of got to treat it year at a time. After how many years will the two cars have the same value? You could say 5 years. Is it compounding? Yeah, if it's per year, you can only really, I'm going to say 5 years. I mean, it's not really that accurate. It's really this, but yeah, I guess they want us to do that. Okay. Instead of using the 30 grand which she had saved for a car, Talia had considered investing her money. She intended to invest in some of the amount What the heck? This question is wacky as heck. Instead of using the 30 grand she had saved for a car, which is Talia had considered investing her money. She intended to invest some of the amount at this rate and the other at that rate. If she invested it for 3 years, she worked out that she would earn that much interest. How much would she invest it? I feel like there's too many unknowns. You can't solve a question when it has this many unknowns, right? Because I can just choose a random amount and then make it work. I mean, let's just do some brainstorming. The way I see it is, this is a brand new question, and like whoever wrote this book is just sort of clutching at straws. There's no link. So there's 30 grand, that's your initial amount, right? And then that times the fact that she splits it and we don't know how she's splitting it means that I don't know what direction to go in. Let's just pretend that okay, so are we imagining that the 4.25 doesn't matter? There's going to be a bit of a pause on this while I consider this. She's got 30 grand and she splits it. So 30 grand minus A, and I'm going to say that that's the amount she split. That amount times whatever rate times 1.065 for, how many years was it? 3 years. Plus whatever A is, whatever she moves away, times 1.0425, and that's for 3 years. So see, this is a little trick I'm doing. I don't know what the split is, but this way I'm making it so that there's going to be the pile of, like, let's say A was 10 grand, so that's going to be the 20 grand because it'd be 30 grand minus 10 grand, and then so this would be the 20 grand split, and then this would be her 10 grand because that means that, yeah, so we've linked them together. Okay, and so what if we add those together, we will get our 30 grand plus the interest that she earns, 5414. Yeah, I can never decide if it's better for me to show my problem solving on camera or to show you like a clear explanation on camera. I think in this case it might be clear enough. So now she's got this amount that she's investing at that rate for 3 years. She's got this amount she's investing at that rate for 3 years, and then this is the value she ends up with, right? She's got her initial amount plus the interest. So now if we join them all together, we might be able to just build an equation that we can start solving from. Oh yeah, because we're going to get a number here. Yeah, it's just going to be, yeah, it's going to come out pretty nice actually. Okay, you could type this straight into a calculator and it would get it right. But what I'm going to do is I'm going to just put it from left to right for you. 30 grand, right, minus however much she splits off, times, and now I'm going to find the answer to this, 1.065 to the power 3, 1.208. It's an ugly plus that A amount times, and let's work out this one here, 1.0425 to the power of 3, 1.133 equals, and then that combined amount, so that's just going to be 35 grand 414 bucks. So now let me move this across for you guys so we can see a little bit more of what's going on. So now we have no logs to do and like not very much algebra to do. This was where the algebra came in, so that's what makes this possibly an excellence question. I mean, when they're all combined together, I don't know if I'd give an excellence for this one. It's got to be more joined up for NCEA to give an excellence for that. But that's all good. Then we have to times that by 30 grand. Move it all over. So much calculation. That's all good. Okay, 30 grand times 1.208. Ooh, it's not a bad number. 36,240 minus 1.208a plus 1.133a equals 35,414. Now from there we will get our a's together. Probably should do this in my head, but I don't really want to risk it. 1.113 minus 1.208. That's our a's together. So what I'm going to do is I'm going to move that over here to make it positive. So it's going to be 0.075a, and then I'm going to bring this over to here. 36,240 minus 35,414, and that's 826. And then we just solve. So A is going to be 826 over 0.075. 826 over 0.075. Okay, so A, the amount she split off is 11 grand and $13.33. I guess it was kind of a cool question. So that's A. Let's just make sure that actually answers the question, because they might, I don't know what value they want. How much would she have invested at 6.5%? Aha, it's not the question. So that means this is the amount that she's investing at that 6.5%. So we have to go 30 grand minus that answer. 30 grand minus, and I'm just going to go shift answer. Right, so the so it's going to be 18 grand 986.67, and I should probably write that in a sentence. At 6.5%. Yeah, I'll hand it to them. Decent question, decent question.